Director at User Experience, GE Digital. He has a lot of experience in many areas. He's been involved with educational software. He was with, where in the world is Carmen San Diego, GBH, oh gosh, I'm sorry, I'm forgetting, ZD News, and now he's with GE. I probably left one out there. So without much more ado, we're going to switch over. Joe?
Okay. No problem. Hi, folks. I just thought I'd say, I don't know if you know this, and I don't want to give anything away in the press, but GE might be coming to Boston, and we may have some job opportunities. So I'd like to add to the list. I didn't want to jump in. And by the way, in seriousness, it will be across the gamut. So anything from engineering, cloud-based engineering, on-premise programming, as well as user experience and sales roles, management roles, everything. So it's across the gamut. I'm in those meetings a lot lately. So I just want to start out just level setting what we're really going to talk about today. It's going to be a little bit different than just talking about the Internet of Things per se, the way that people think of it. For instance, most people's exposures to the various devices they have, like phones, iPads, their televisions, Alexa, Google, etc. The idea that I can get my information anywhere is in your face, and you pretty much can pick it up, and it's taken for granted that it's going to happen. Industrial Internet of Things is a little bit of a different animal because you have a lot of sensitive information, and I think more importantly, it's sensitive information people will actually target depending on who you are. So a lot of GE's customer, and GE's itself it's its own customer, but I mostly go to outward-facing customers. So we're actually doing installations in other big enterprise-wide. You can guess who they all are, but people who make soap, people who make plywood, people who make tires, pretty much anything, medical industry. And so there's a lot of sensitivity. There's also an element of speed that's related to a lot of what we do. So we talk about the industrial Internet of Things, and so people go, oh well, it's our customers, our users, our facilities, our assets. Those are the things. I think of it much more as nouns and verbs. In other words, as a UX person, I care deeply about the nouns, but I really want verbs to happen. I want outcomes. It's not good enough to say, okay, I took all this data, I put it up on the internet, and I gave people a simple way to access it. It has to be the right simple way to access it. So you have to streamline a process when it comes to people. They want to go home. For an operator, the driver is, I want to go home earlier because I was able to finish my task. For the CEO of a company, he wants to be able to quickly establish what figures and numbers have come in and how he can make better decisions for tomorrow. There's places and facilities, and a lot of times, personally, you think of Google Maps, things like that, but this is really about analyzing information. Where are the trucks? Where do they happen to be? Where is your product that's been shipped? So really logistics and analyzing those logistics. And then things are assets. Now, specifically in the manufacturing environment for you folks that are in that world, assets is a very tricky word. The simplest way to put it in this forum is assets are the physical machines. They're the CNC machine, which are the machines that actually, if you want to think of it this way, drill out the new Mac PowerBooks out of the single block of aluminum. It also could be just as simple as a drill press. But assets also in our world are the sensors that are on the machines. So if you have this turbine, you might have 1 million sensors in it. If you talk to an engineer, and I'm just originally a visual design guy, he'll go, well, we have 1 million assets on that turbine. And I said, isn't the turbine the asset? And they go, well, no, it's actually those individual numbers that get called in. So one of the examples I just love to give, because I think it boils it down for folks, this is an Edward Tufte example. And Dr. Snow in 1854, he was asked, there's a cholera outbreak. We don't know exactly where it's being caused. We know that water contaminated water does that. So he was one of the first people to actually go, I'm going to find out where all the people were sick. And so he did one of the first scatter plot diagrams. Now, he finally figured out that the one that's right in the middle here, that's the bad one. These people were cases where fish was shut down on a Wednesday, so they walked into town to get their water. But when they did this, the cholera outbreak stopped. The industrial internet, take 1,000 of those and stack them on top of each other. With different outbreaks, with different symptoms, with temperature, with weather, everything else. That's really what we're managing now. So it still comes back to humanity. It still comes back to something you can analyze. But the reality is there's many, many, many overlays. You're actually looking for the situations that you human beings cannot normally predict. It's like I had no idea, that when the temperature was below 30, the O-rings on the space shuttle would freeze before launch and would actually start to deteriorate when they were heated up too fast and cracked. It had more to do with a weather report than it actually did with any of the engineering on the specific device. If they had just actually launched about, they said 45 minutes later, that disaster unfortunately wouldn't have happened. So going from that, what does GE do? So, correct me if I'm wrong, but do most people think of washing machines, dryers, air conditioning units? Okay, we don't do any of that anymore, actually. That's actually not part of our portfolio. We do still do the light bulbs because, hey, it's our corner of our brand, but we're also doing some really interesting things with lighting that have to do with extended technologies. But a lot of people go, oh, well, this is what you do. The reality is we're really shifting our company. And what we're shifting it to is we actually make jet engines. We do a lot in energy, a lot in healthcare. Anyone who gets an MRI, you'll notice that half the machines out there are actually GE branded. We do speculation for oil and gas. We do the big wind turbines. And GE Digital, you'll see, is that new box down at the bottom. And what we're really doing is we're trying to tie all of this together with the digital thread. So we're trying to make it so that the Internet of Things, we gather data in all these areas. We just don't, like most companies, we didn't have a plan for how it was really going to be put together. But it's not just about us. We're a good case study in of ourselves. That's why we feel like we're pretty qualified with the people. I won't put myself in that category. I'm not a data scientist. But we have folks that are really familiar with this data and know how to manipulate it. And we want to do that for external customers as well. So that's our mission. So if you think about it, when you talk about Thomas Edison, he basically said, the world needs something and then I proceed to invent it. I know that there was a debate coming into this. We had some talks before this happened with the team that you've seen tonight. We were talking about what's the real gravitas to user profiles and personas. How do you use those? How do you integrate user feedback, things like that? And one of the things is we have to be qualified as UX people to have a vision for how things should work, not just make them better in the way they work now. We have to see the unforeseen events, not just the ones that are easy things. On the flip side of the coin, I can say I spend a lot of my days in meetings convincing people that, sometimes a straight line is a straight line, and you just should draw a straight line and get to the next thing. So it definitely, without question, is a balancing act. What happened between Thomas Edison figuring out how to create a light bulb that everyone could use was the Henry Fords of the world figured out how to take a pre-existing product and manufacture it, which is where we are right now. I mean, fortunately or unfortunately, you go to a factory in Michigan. It looks different. It has robots on it, but the reality is it's still a line. It's very much still like this. Those carts actually still might be there. So it's a very, very interesting environment. So lastly, we're a digital company. So some folks here might have heard of Predix. That's our Internet of Things cloud solution. I work with Predix Solves, so their cloud solution, but I also deal with GE on-premise because we deal in sub-second data feeds. So someone actually watching a line with 1,000 diapers flying by in a minute, and that kind of data feedback is not necessarily something you want to send up in the cloud and back through your system, but we will share that information for our cloud so other users can manipulate that data and predict, when things might go wrong or their projections, etc. So I just want to stop here just for a minute. And I don't want to freak anybody out and make it draw out the conversation too long, but any questions about the direction or what GE is doing at this point?
You said earlier about a balancing act between a straight line being a straight line and imagining how to get from today to...
I think the thing is that I was actually talking to some folks earlier tonight, and one of the things that you have to be careful of, especially on the UX side, is we as individuals tend to be creatively minded. And so we love to come up with creative solutions. And sometimes you can design yourself right out of a solution because it becomes impractical. That does not mean, by the way, your solution was a bad idea or wouldn't necessarily work. I do think there is an inherent flaw that I've seen, at least over my career, where I've even done this. I've designed something that someone in the sales team, or my management, resonated with and said, this is awesome. Let's do it all right now. We did it all right now, and we put it in front of the user, and they didn't know what to do with it. Because we hadn't graduated them up the path. We hadn't first said, like iTunes did, not that iTunes is a great example because it never has come to its fruition as an interface, but nonetheless, it's database management. If you had thrown everything you could do in database management in iTunes on day one, no one would have used it. They would have been too confused. So sometimes you have to acquiesce and say, my first step is going to be making the simple, straightforward, the line, a little bit better, and getting those users teed up so I can change their behavior. So your thoughts have to be tactical in how you execute it, but strategic in why you're doing it. You want to make sure that you move and elevate them as you go along. I don't think we as UX people take enough responsibility for elevating our users to the next level of usership, of engagement. I think sometimes we get caught, and everybody, including me, get caught into the, I got to get this done because I got to get these wireframes out by X date, and sometimes it falls away. What are we really doing, and what's going to be the long-term impact? And there is such a thing, by the way, folks, as UX debt, just like there's technical debt. So just from a process perspective, I just want to switch quickly to process. So this is kind of how I personally look at the world and how I promote this within GE. So I think that we make a promise to our customers, and that's the CX. So we have a promise of our brand. We are always going to deliver on-time data relevant to their task, and we're going to collect data from them that will make their lives better. If we do that, we're doing our job. That's the core promise. That's what we're telling our customers, and customers translate, just so you know, to dollar signs. They're the people that are paying us. We don't really get paid by the operators, per se, but we do get dividends when they work more efficiently. So it kind of overlaps like so. We have our customers who touch upon that core, which we as GE kind of own, or your company owns. You have the UX, which is the experience, so everything. It's when they pick up the phone to call you for service. It's when they get the package in the mail if they're not downloading it. What format? Are you delivering it on a DVD, or are you giving them a really cool thumb drive? Everything that goes to that, and giving them a UX experience. And then finally you have the UI, the place where we live, which is how are they going to interact with our system. And so it is the pedal hitting the metal, so to speak. So you engage your users. All these things, I'll circulate a PDF, so I know this slide has an inappropriate amount of text on it. And believe me, I parsed it down, but I did that so I could leave it with you with a PDF. From there, it's like, who are you designing for? So you always, always, always need to tell a story. If you can't tell a story about what you're doing and you don't have a username engaged in that, so we actually have different names, like Carmen is our integrator. So I walk into a meeting and say, we're going to discuss Carmen today. Everybody knows I'm talking about systems integrators. And we talk about that person as a person. So, for instance, someone said to me, oh, we're going to change our syntax for our data entry system for our automation products. I said, that's cool. I said, where does the user see that happen? And they said, oh, it actually doesn't happen in our application. It happens in the model configurator application that we have. So the integrator would see it there, and I said, what would they see it as? Oh, in a drop-down, they'd now see that they can get OPC UA, you know, databases, and they can access those. And they would think, and I said, they would think that was really cool? And they said, yes. And I said, okay, so the story that we're writing is actually about our model editor, not about our current application called Simplicity that we're putting this feature in. Because we're actually putting the code in one application, but its after effect is in the place the user sees it is over here. You have to understand how everything combines together. So when I take a look at this, I often think of code. Okay, you have your business, you have your operations. So I've said this lately, and I almost feel bad saying it, but it is true. If I did 100% operator satisfaction, made everything right for the operator, I would probably fail for my customers. Because customers have goals. They want to get something out of the application they're doing, and if you make it bend over backwards just to make sure that every single thing is so simple, you might actually be stretching out the timeline. You might be just saying, hey, it's easier for them to just walk over there and hit a button. We don't need to design a PLC, which is a controller, for actually turning that button on and off. Someone just flip the switch. And the reality is, where those two bubbles exist, you have the satisfiers for both. That's when you start a project, you should be looking for those. You should be looking for that overlap where you go, you know, we could really improve the user interface, and that is directly on point with what the customer wants. And that helps in a lot of ways. That actually helps even company culture-wise. I don't want to, you know, make us the healers of the world. But the reality is, if you have the operators understand why they're being asked to do something, and they go, well, that's a good reason. I could get paid more. Then they're going to do it, and the business is going to like it because they fulfill on their business goal. So as an outside person, as a UX person, you're looking for advantage for everyone in the system, because if you have 2 or 3 of those and then all the rest is technical gobbledygook and design reasons and we did it because that's our style, you can actually do that now because you have 3 points. You can put it on a bullet side or in an email and say, we succeeded in these 3 areas for the 2 groups. So I'll just spin through this really quickly. This is just an overview of how we really look at design thinking. You know, we do take a formal approach. It isn't completely loose. It's not quite as stringent as it used to be when you wrote the creative briefs, but we do require a level of functional requirements. We need to have those user personas written before we start anything. Because if you don't really have that story to tell and everyone understanding, most importantly, everyone on your team understanding the same process, you're already starting off in a bad spot. So, what is Predix creating? So one thing that wasn't mentioned in my bio, and I didn't put it there, was that I have a little bit of a Lego problem. And I have a little bit of a Lego problem before it was fashionable. So it's been quite a while. If you go into my space, it can be a little embarrassing if you don't know me. So you start out with a concept, a CX concept. And you have this option when you build a platform like Predix, like any platform you're going to put all this stuff together in, and you say, do I want to go custom or do I want to go modular? You want to go custom if you're in the healthcare environment, where it's absolutely critical it works through everything because it has to be completely tied off. There's so much regulation and everything around it. You kind of be crazy not to just embrace the fact that that's the way it's going to be. But manufacturing, can you go with a little more modular because everyone has OEE, Operation Equipment Intelligence, OEE, yeah, Operation Equipment Efficiency, and everybody has downtime requirements like when the operator has to go to the ladies' room. You have shutdowns, you have machines being cleaned, all that stuff. All those environments, whether you're making cookies, tires, or jet engines, that all happens. So there's common solves. So you have to look at the fidelity of your solution. So in the case of building something for the industrial Internet of Things, you want to look at it from the perspective of modularity. And maybe you don't have quite as much fidelity as you would with a totally customized solve. So we're shooting for this. We're shooting for the idea that you can build a platform, everybody can go, oh, that's a VW. But at the same time, they go, you know what, I may not get everything, but right now I'm going to get the general form, and everyone's going to be able to communicate the same language. Now, 20 years from now, 15 years from now, maybe the fidelity is so fine you can't tell the difference between the two. But until we gather that data, which I want to stress, I don't think anyone has. You know, we have customers that have trigabytes of data, more. And they've collected it. But we have to go back, because it was collected 20 years ago, and put it into some format that even can be consumed. So it's not fair enough to say, oh, you've been collecting this data for so long, we're just going to plug it in and it's going to work. There needs to be a gestation period where this comes through and goes through the system. So just to give you an idea of the CX concept and modularity, you know, it takes advantage of the fluid nature of what's going on the internet itself. So the idea of, you know, there's no one way to do anything. So if you make it modular, you can make multiple modules. Or maybe you don't make multiple back-end modules, you just make multiple UX modules that represent the data that's behind there. The data is always the same, but the way you present it, you get better and better at visualizing it. So the idea here is, I can take all the same Lego pieces, and I can build different cars. So I can customize them enough to appeal to all those different audiences. And how does this translate? Now focus on the row of cars. That translates to users. They all get a slightly different composition based on what they're doing. So in general, this isn't an exhaustive list, and I have provided this in the deck. But essentially, we have product developers, who are folks that are basically saying they might be on the customer side, so they're going to say, hey, we need an application, we have a need here, we've identified it, we're either a consultancy or we're part of corporate IT or the facilities management. They usually don't have an integrator on site. Usually it's an expert that comes in for the time being to stand up a plant or a series of plants. So that person comes in, and that person honestly knows our software. So they are an expert in either simplicity, which is one of our HMI, human machine interface applications, or it's iFix, which is the other one. They will work on that and actually build the physical user interface screen. So one of the very interesting things is that you will all find yourself, if you throw yourself into the industrial internet, I'm sorry, but you will not be the last person to touch your design alive. It's very likely that you will make the bits and pieces that go together, and somebody else, maybe less talented or less creative, may put those pieces together. So you have to ensure a lot of guidance in the actual development of those things so they fit together well. You have to have, you have basically operators. Those are folks that are sitting right in front of the machine. They have direct responsibility for what is going on now. So they don't care about history. They don't care about the future other than if the system can tell them in 5 minutes because of the oil pressure, this thing's going to fry. And so you have to shut down the machine. Other than that, they are in the moment people. Then you have your maintainers. Maintainers are an audience I think in general will be dealt with later, unless that's the reason you were contracted and focused, because it's a whole different, I could have a talk on that alone. It's a whole different view of the world. They're the people that actually do treat the sensors I was talking about as assets as well as the actual machines themselves. They're the one group that I'm going to talk about today that looks at it that way, because if a sensor breaks, it will show that the machine is off. Is the machine really off? A tree fell, did it make a noise? It did to the maintainer. It may not, the operator doesn't care. Doesn't see any data coming in, thinks the machine's shut down, and it's as catastrophic as if it did. So you kind of have to put that into your mental thinking. You have systems administrators. Those are the folks that will maintain the system after it is installed. They'll assign the new people that come in for a day of work, etc. You have analysts, the people that take a look at the data, the issues on the factory floor. And then you basically have managers who need complete transparency over the process to say, is rebuilding this factory or rebuilding this line or making our product slightly differently worth our while in the long run? And the Internet of Things will help them do that, because this is the on-ramp. If you want to think about it, what I'm about to show you is the on-ramp to the industrial internet. You have to gather the data first. There are many, many organizations out there, quite frankly, that deal with the analytics part of it and go, we're going to show you how cool you can predict the future. except they don't have any real way of gathering the data to go into those analytics engines. This is the way. They have to do it through the HMI at this point in time. In the future, maybe not. Maybe they'll be so advanced and we'll have controllers that are so advanced it picks up the data and throws it directly into the analytics tool and we don't have people involved at that level. I think most people agree, we'll always have people at some level involved at the manufacturing facility. It just may not be in front hitting a button all day. And I would hope in some cases it's not, for their sake. So this just gives you an idea of everybody gets a slightly different view. You might have the tablet and the phone. You might have large screen. You have control touch screens. You have asset configurations, so actually building databases. So it goes all the way through the gamut at an abstract level. So now we get to the fun part. Trouble at the TP factory. So let me give you a little bit of overview. I cannot say who the TP factory was, but a few years back, I actually was going there as the UX guy to this factory of one of our customers, and they were having some really bad problems with production. And basically the situation was they were experiencing lots of challenges. They were operating way below expected levels. So like, is this even worth it? If a big seller that has a blue logo with a yellow asterisk had a sale, and they decided to put a sale on this toilet paper, they weren't sure if they could support it. So it was really interesting. So the observations were the environment was air-gapped, so in other words, they did not have any external internet connection, which is very typical. Linear workflow, just continuous manufacturing, making the same thing over and over again. This is not a shift over. It might shift to packaging and get branded as one kind of toilet paper, one to another, but other than that, they're identical product. It's a segmented work environment. They had a lot of carts, and they had something that we don't in manufacturing like people to do, which is on the floor warehousing. They actually had taped off blue areas where they'd have carts of stuff, like the tubes. And they'd have them there, and they'd have them stack up in the middle of the room, and then they would be waiting for the people who take the tubes and put the paper actually on it to get it, and you warehouse on the floor. You don't want to do that. You want it to go through as continuously possible so you don't have any mess at the end of your shift. That wasn't happening in this case. And the fun part for me is I got to see a critical alarm where they had to shut down the line. Now, they weren't happy about this at all, but I was overjoyed because I got to see, frankly, our software, frankly, some of our competitors' software. It was a mix. It's rarely all one. Just have a whole series of, I'll be honest, epic fails. Mostly because people didn't know how to use things, or the system wasn't quite what it should be, and they did have other external problems that were outside of the software. So basically, we wanted to really go through and find out, what are you looking for? You're looking for the roles that are engaged. Who's running around where? Who's getting affected? What are their touch points? Communications methods. How are these people communicating either with each other, with the process, or the machine? And then information flow. How is this stuff going around? Is it word of mouth? Is it sneaker net? Is someone typing something in a keyboard with big thick gloves and keeps on miskeying and no one can read what they do? And then what are the pain points? I've met plenty of operators, by the way, that they were given an iPad, they do like the idea, but they go, these are all quality checks. I'm just going to do them at the end of my shift. I'm not going to do them as they come through. And of course, that's not the plan at all. They want them to do it as they come through so that they can stop the line if the quality check is bad. But they're like, I don't have time for that. I have a quota of 5,000 things, so I don't want to do that. So you have to figure out ways of building it into the workflow so that they actually do it when they should be doing it, or find out if there's a better way of doing it that's maybe offline and outside of their bailiwick, because it is getting in the way of their quota. By the way, I just have to say, you don't know how long it took me to find this photo that was a toilet paper meeting. That was tough stuff, people. Probably spent more on that part of the presentation than anything else. So, hearkening back to my GBH days, I had to throw Elmo in there. I'm going to ask you to just Just bear with me for a moment. This is a Sesame Street video, but this is actually a Sesame Street video of a toilet paper plant making toilet paper. So this will give you an idea of the kind of environment this slick new software is going to exist in.
Let's take a tour of the factory. Find out what this pulp is about to be in a big machine of the milk. Goodbye, got to get it very wet because it's very dry. Got to mush it, mash it, make it into slurry. Hurry, get rest when a mess is occurring. Tidy it up, bring it down, press it flat, wind it up like that into the thing called the master roll. The that's what we take home, right? No, that one's way too big for us as it's going to the bathroom. It wasn't quite complicated enough. Don't want to add to that a toilet roll bigger than a Cadillac. That'd be sad. We couldn't lift it up if the roll ran out. Would we hire a truck or one farm forklift? Just the thing to back it up. Now bring it into the swing of the mechanism. Yeah, we're rolling out like generously rolling out yard after yard of the bath issue to the benefit of the skinny little cardboard tubes. Uh-oh, they're naked. Better get them dressed. Where did you expect? They'll roll to next, but they headed it directly to the grocery store. What are they still in the factory for? Not too heavy anymore, that's true, but still too long to fit into the bathroom. So we measured them out and we cut them the size so they look like rolls we recognize. See how they ride down the line with these. It's hard to believe they used to be trees, so please just use the amount you need till we take another trip to the factory. Okay, bye-bye, CP. Bye-bye.
I wish I produced the video. So now you know what we're talking about. And by the way, the alert that happened when I was there was right after the cutting process. It jammed up. And it was like watching a car accident happen on the George Washington Bridge at rush hour. It was just unbelievable, and they're running around doing all kinds of stuff. So with that, I worked with several people, and a very talented illustrator, and went through and we storyboarded. We harkened back to my TV days, and we storyboarded the situation. Now what I'm going to walk you through is two different situations. The one that actually happened with some editing to protect the innocent, and then a second one that would be what the industrial Internet of Things would do for a situation like this. So first off, trouble at the TP factory before. So first you have Larry. I'm sorry, Harry. And Harry's walking down the line. He's a line engineer. He's specifically managing probably one, maybe a couple of lines within the factory, and he checks in with everybody to make sure everything's going okay. And for instance, his responsibilities will be to make sure that materials are delivered to the right spots when they're starting to run low. He's going to react to those three-colored lights, the and-on lights, and walk over and find out if there's an issue of some kind, if something rolled up. And so he's there, and he notices a little red light. He's one of those and-ons go off, and he goes, oh. So then Harry walks over to a standalone kiosk, which may not be close at all. And you've noticed I put little clocks here. So this is how long this issue is taking. So he has to walk down, and he has to go find a kiosk, because it's not attached to a sheet. Or it's not an iPad. So he goes there, and he sees what's going on, and he clicks on a banner at the top of the screen that's red, and he looks at the HMI screen that the operator's looking at. This I found particularly amusing. Now I told you that it was a jam. He's looking at a pie chart as the analytic, as the visualization for how the jamming occurred. I don't understand that. That is so far an extrapolation from what was actually going on. It just, I had to ask him afterwards what it was, and after he even explained it to me, I was like, I get that it shows what the probability of it being what, but I want to know like what the issue is and what's the recipe to solve it. I don't care what the percentages are. Meanwhile, Sue is back at the spooler. She's the spooler operator. And she sees an alarm and moves to her local HMI, which is pretty close to her. It's usually on a desk in the center of the line. And she immediately looks for some way to find out why it's not running properly. Harry walks over to Sue. Now at this point, it's 10 minutes later. Harry walks over to the other side of the plant, Sue's workstation, going, what's happening? So they stand over each other's shoulder and go back and forth to the keyboard, and they go, I think we need to call maintenance. So they call Sam. At 24 minutes in, Sam gets radioed. So his method of communication is radio. And he's not anywhere near. So he has to walk maybe from another building, because they don't keep very many maintenance people around, because, quite frankly, it's enough expensive, because they know everything. And he goes through, and he said none of the recipes that he has, either in his system, or usually it's in a binder, you know, aren't working, aren't symptomatic of this, don't know what to do. So now we have Ian. So I know I'm switching gears, so this is an inset in the movie. Ian is on the portion of the line before Sam. And he's realizing his stuff is starting to back up. It's not moving on. No one's taking the cards. So he's there going, oh, I heard there's a problem with the spooler. So Ian calls Mary. Mary says, yeah, we have a problem. And then Mary is actually the plant production operator, and Ian asks, do I have permission to either shut down my line for now because I'm producing stuff that's not getting used and it might just sit there. So Mary's kind of annoyed, but she tells him, hold on, I want to find out what's going on. After talking with Mary, Harry also shuts down the spooler so Sam can investigate. So now they have two portions of the line shut down because they have one issue. We are now 41 minutes into it. Sam takes over Sue's HMI. He changes a few things to diagnose the problem. He figures out the problem is the cooling system. So it overheated. Sam heads over to the spooler, grimacing. It's happened a couple of times. He goes, and there's actually a redundant system, and he changes it over to the redundant cooling system. They have to restart. And then finally, 45 minutes in, Sam radios back to Harry and says, you're all set, Harry and Sue, and they start up the line again. So they lost 45 minutes in production. It's 5,000 rolls a minute or something. That's a lot of production to lose. So is the issue done here? No. Because what happens, and I didn't bother to put clocks on this, but this process does change, is that afterwards, Sam, being the maintenance person, now starts to talk to the people that I refer to, the people in the building with the fake pond out front. And those folks are basically saying, how can we solve this problem? We're running numbers on it. So Mary calls in, asks him to start the tube line again. Joanne is the plant manager. She is not happy about any of this happening in the way it happened, that it shut down. Irritated Mary goes, okay, I'll take care of it, Joanne. She goes to Fred. Fred is their analyst. He's the guy that's actually going to take a look at the numbers that came out of the system coming the other way. And he's going to analyze what's going on. So eventually, Fred and Sam get together, and they figure out, you know what, we just need to put in an additional cooling system in there. Just get rid of the old one, get a better redundant system. We'll be much better off. Sam goes off and reviews his option. Fred and Sam return a proposal to Joanne, because she's the plant manager. And, you know, there it is, Walmart. Joanne hastily approves the purchase of $2,500. It's a no-brainer at that point. They probably lost, you know, thousands, $50,000 in the 45 minutes more. And then Sam makes the repair and management system, and it finally gets closed. Keep in mind that entire process is probably mostly on the phone and paper. It's not a digital process. So, in a world, what should it be? The after. You'll notice I have a lot less text on this one. Harry's walking along. His phone vibrates. Gets a message. There's a spooler alert from the system. Sam, she's on her system. She gets a notifier right on the HMI that tells her exactly where the problem is. So she just knows by her own mental geolocation, even if this is an abstracted view. I will stress they do not need to be exact replications of the plant floor. As it exists, it can be the equipment. We found that it's too hard to duplicate every single plant floor, so I wouldn't want to lead someone down that path. And at the same time, there's a tablet alert to Sam telling him one of your pieces of equipment is having a problem. That happened within the first minute. We basically have a communication, a text communication back and forth, probably more like a blog than email per se. It's really feedback and tracking the information. But in other words, Harry doesn't have to walk anywhere. He's right there, he's chatting with Sam, they go back and forth and say, yeah, get someone over there to fix the problem. I'm sorry, I said Sam, Sue. And they say, get Sam over there, and Sam has a different view of the system than the operator does. Because his focus is a lot more at a base level. So that's why I said it's really a different kind of user. There's always an assumption that says, oh, the operator screens are the same screens we can give to the maintenance person. And that's not true, because they're actually worried about the gears inside the machine and everything else. The operator isn't worried about that. They're just worried about the part that goes into the machine, the part that comes out, and what they have okay. So this is a huge amount of work to actually get this to work, which I'll be honest is one of the things that we're going to focus on, but we have to get all that other baseline set in order to do that. From here, Ian's now notified, don't stop your line. He gets an alert, slow it down. Because we found out within 2 minutes that there's a problem. It most likely will be resolved within enough time that he doesn't have to completely stop the line. Mary glances at her machine, either at her desk or in the control room, and gets the same alert, and she immediately gets on the phone, starts talking to people and saying, hey, we got a problem we need to deal with. Can we do this? From there, Sam and Sue kind of diagnose, because Sam walked over, at this point, he opens up his special screens from the operator screen that show all the diagnostic information. He goes, you know what? We should just switch it over. We can solve the problem later. But we have to return the system, and the system diagnosed itself, so we knew what the problem was. 5 minutes in. Six minutes in, it's rerouted, respun up, and start up. Ian gets a notification that he can start up his line at full throttle again, and you're back to normal operation in 6 minutes. Now, even if I'm completely off, if you made it 12, it's still over more than 100% of what was lost in the other scenario. And the other part that's the scariest part is that in the other scenario, which is the real world scenario, none of that data is gathered for future use. They only know what was fixed, and they know what the problem was. They don't know the path to get there, so none of it's recorded. It's all, recorded in some operator's mind, and it's gone when that operator leaves. So that goes into the next portion, which is the maintenance task is created. So a maintenance task is now created, but now we cut out a lot of the middle people. It's basically, okay, have a problem, we need to replace it, puts in a warning and a request to Mary. Fred still does his analysis. He goes through, he actually, has maybe weather.com. Maybe the reason why the HVAC system didn't work was the day was hot. Maybe they need to look at some other reasons why it failed. He graphs that out, figures this out. Gets back to the folks managing the problem, and she says $2,500, no problem. No nasty comment about Walmart because they didn't shut down the factory for 45 minutes. And finally, Joanne gets a notifications, and it's been resolved. It just pops up in the corner of her screen while she's working in Excel or some awfulness. A user interface only a mathematician could love. My wife's a mathematician, by the way. So this gives you a little bit of a preview. I'm a little under time. And the last thing that I'd say is in terms of are dealing with responsive designs for each level. I would say there's an interesting thing, and I do make a delineation when I talk to at least my folks. There's responsive design and there's adaptive design. I really prefer the latter. In other words, I don't expect everything that you're going to do on the iPhone is going to be, you're going to give the same functionality on the iPhone that you are here. I don't think you should. I don't think it's the right thing to do. I don't think it's the right platform. And there's also a lot of reasons, like you work in a grinding factory, maybe holding a phone without a tether over a machine isn't probably a good idea. So you're maybe an iPad or above. For instance, Boeing has actually used for years, so nothing to do with GE, by the way, just a case study. They actually use iPads, but they actually had to design harnesses for the iPads because they're crawling around on the top of the plane. They were dropping them off the top of the plane. Not so good for iPads. And so, but we do try to give the appropriate view at the appropriate platform level. And so it's not just about re-visualizing the data for each platform, it's also figuring out what data is appropriate for each platform and then visualizing that. So in wrap-up and summary, I'm sorry to Mr. Edison, but I had to do a Henry Ford quote. And I really do believe this. As I hearkened to before, was talking about the fact that there was some discussion around the usefulness of personas. I think from the perspective, I think this kind of sums it up. If I were to go to my operators and do a straight interview with them and say, what do you want? They would tell me all kinds of enhancements to their current system. That's what I'd get. But I wouldn't, they're not, and it's not that they're not smart people and it's not that they don't know what they're doing. It's not a question of respect. It's a question of, this digital stuff isn't their bailiwick. So you have to be the expert for them and say, okay, but I want to understand what the underlying problem is. Because most of the time the things they're telling you are symptoms of the problem. They're not the actual problem. I know for the visual designers in the room, in my early career, I would hear from many, many a client, we need to make it red. Why? Because it's important. And if you make everything red, then it doesn't matter because everything's red. So you really have to work around that you're the expert and you're trying to help them get to a result that they want to get to. So there is an importance to user profiles. However, you cannot use them as the holy grail or the Rosetta Stone to get to everything you're going to do. You have to digest them properly and figure out how they work in the solution you're trying to do. In my meager opinion, it's about the journey. Tell a story. If you can't tell a story, if it's about data, code being changed somewhere so another database can accept it, probably should reevaluate whether that even requires a UX. Or find out where that UX is, sniff it out. It's about process change. One thing that I think that everyone right now is guilty of, probably in the Internet of Things, forget about the industrial Internet of Things, is that no one's understanding that you're asking the user to change their behavior. Now in consumer it's a little easier because they're driven by their own needs. So if you have something that they want, they'll go through a couple of fire hoops to get it, and then it'll be something they learn to do forever. But in the industrial market, it's a little tougher because it's your job. It's kind of like saying we're going to give you a new package to do all your wireframing in, and we're doing it because you can share it with everyone, and isn't that great? And you go, I got to go learn another wireframing tool. It's my 5th one this year. But it is about process change. So you can convince people by saying, but everybody can work on it in automatic version control and all those good things, and then it's okay. But you have to figure out how it actually benefits the end user and bring them along for the journey. Manufacturing industrial space, we are trailing edge. So we are as far from bleeding edge as you can possibly get. You can go on any factory floor, and as long as the building was standing in the 1800s, I guarantee some of the equipment that they're using that they're still using to manufacture is from the 1800s. They're reticent because they have an established system. They have a lot of custom hardware. This is not a fake or fictitious problem. I know a lot of people who have come out and they're UX people and they want to really, and technology people, not just UX, but engineering, they go, oh, we can do this totally different. It's like, okay, but you have to to understand, you have to kind of put engineering principles, direct engineering principles, cause and effect. If I do this, how much better off will I be? Will I get a different product? Well, no. Well, if I'm not going to get a different product and you're asking me to spend $5 billion to redo my factories, what's going to be the advantage? Well, you'll be ready for the future. That might not be enough to drive them. It has to be more than that. Our customers are reticent to change. They will do it, but they have to be shown the value proposition. That's why I stressed at the beginning that the customer experience is a really important component specifically of the industrial Internet of Things. Not so much for the industrial Internet, or the IoT alone. Because consumers will do what they want to progress. But there's a cost, a huge cost associated with the industrial side of things. It's not about an app changing a single behavior. So you're changing everything about their work stream. And quite frankly, that's the other side of me, that's the anarchist in me. If you're going to change one thing, change it all. Give them a vision of how they can change it all. Don't tell them they have to do it tomorrow and spend all the money. Show them a pathway to it. That's the trick. Because someone said to me once, I was in this meeting and it was with a bunch of GE people, we were talking about the future of manufacturing and automated manufacturing. And someone said, pontificating, I wonder what the end game is. And I said, well, the end game's easy. I said, robots run everything and we go home. I said, that's not a problem. I said, the path getting there, the transition, the garnering of the data, the use of it, humanizing the data so people can understand it so that they can improve it. So eventually we get to the point where the tasks are no longer those manual tasks. They're more analytic tasks. That's great. I guess my presentation's over. I might have run out of battery. I shouldn't have, though. Yeah, I'm dead. I can continue to talk, though. It's very important to understand that it's a different world, and you do have to convince that audience, and you do have to ramp them up to it. And you also have to understand time is a major factor for them. For the analysis part, I'll give you an example. It's kind of interesting. Everybody knows the turbines, the windmills. So you have the windmills, and that's not instant manufacturing at all. As a matter of fact, you know what your manufacturing environment is? The wind and the ocean. So your predictor is actually looking at weather and meteorological stuff and satellites. And they call in through each one of those towers calls in with a cellular phone device every 5 minutes. Not quite sub-second management. So could that be something that's managed in the cloud? Absolutely. They will never need that sub-second, so they may not use the products that you're truly designs. I might have effect on those ones because they'll be similar and they'll operate the same, but they have much different access point. For running a train and finding out whether the doors are open or closed before you take off when you're on the BART, leaving San Francisco Airport, that might be sub-second. You really don't want the doors open when the train starts. So it really all depends on how you do it, but you have to analyze. So with that, I'm going to open it up to you folks. Got any questions other than, why did this machine turn off all of a sudden?
So, I think I can talk. So when you design these interfaces for the factory workers, how do you test them? How do you get them tested? Do you have access to these workers?
We do, actually. You have to get lighthouse customers. You have to get customers that are going to tolerate you not doing the right thing the first time. That's for sure. We do have a lot of customers, so we can do that. You go in and you show them. It depends on what you're showing people, and I can say, and I don't know who's right. My folks and I, my team, we often debate what fidelity do you need to show a customer. I tell them if it's something as basis navigation and has a lot of visual cues and nuances, I want like a full interactive prototype. Because one little thing off on that, is going to make it not work. You can't do a paper prototype in front of them because they're going to go, how did that thing flip out? And it's kind of like, well, we should have animated it and then they would have known. So that becomes an issue when it's something really, really basic. But if it's workflow and process, I think it's really, really smart to take the wireframes and go through and say, do the steps you do during the day align with what we've done here? not align, and just because they don't align, does that make it better or worse? Because we're actually asking them to change their workflow. And sometimes you have to accept the fact no matter how good your design is, sometimes you're going to get an absolute no, and you have to know when you're getting that, and you have to forge ahead because it's got to change this way in order for the process to become better in the long term. And there's other times where you really have to listen, and quite frankly, it just takes a lot of emotional intelligence to figure that out. Some people, you know, we have a joke, and it's, he was a really nice guy, but he was, you know, Mr. Jensen, old man Jensen. He'd come in and he'd say no to everything. So we knew when he liked something. We were great. But, you know, he'd come in and say, that's not the way we did it. And it's kind of like you've got to watch for those cues to go, okay, but you're not elevating yourself out of the process. But you do get in front of them, paper prototypes. There are some things that we're forced because we have legacy software already, you know, that we're going to produce things in a similar fashion, but we're going to make tweaks. So we put that in front of, for instance, our integrators. So those are the people we really test and say, hey, would this be useful when you're designing a new HMI? And they'll say, this would be awesome. And let me see what the process is. And then we close our mouths and let them walk through the process and see if they can get it. So there's a lot of contextual interviews, things like that. But it does take, I will say, inevitably, even when someone says, yep, you can come out, you know, next week and do a user testing, it takes about, I would say, a month and a half to 3 months to get that really going. Because then calendars come in and they're not going to shut down the line to let an operator come off the line and not be productive, and they have to get a budget, but they want to do it. And so you have to have a realistic expectation of your access. Yes, sir.
So one of the points on the slide that you haven't reached that I'm curious about was security.
Yes.
Can you talk a little bit about how you do the design for security, and in particular, how you handle messaging to users, making them aware of security that they're running into, when security is blocking them, or when security is enabling them.
Okay.
Can you talk about that intersection a bit?
I can. So first off, I have the luxury of being on the on-premise side of things. So security is actually managed by the local IT department, and our software does not go outside of the firewall. There are tons of concerns of our customers and potential customers about when that data goes to the cloud, how secure it is. And everybody in the cloud environment has a lot of work to do to make sure that that's secure. In terms of internally, from a user perspective, it should be completely transparent, as it is with, it would be no different than posting a file to box within your local company network and making sure that file system is secure than doing this. There isn't a lot of difference. The data in terms of its format is, by its very nature, all rationalized. So I was actually talking to an engineer the other day, and he said, the simple truth about automation is that we make all the numbers look identical. So he said, I can't actually look at the raw data anymore and tell that it's a temperature versus the number of people that came to work that day. He said, there's just no way for me to tell because it's been rationalized so it can be evenly consumed through the system. So from a security standpoint, to cycle back to that, it's pretty secure even internally because the data that's being passed is pretty abstracted. But we do have a great concern when it comes to, you know, the question has to be asked, you know, if you can download data from a cellular network to control the turbine, can you call the turbine and make it do something? And so there are really, really smart people I know at GE that do work on that and make sure that it's secure, but it's outside of the purview of the actual operators. That's a fair answer.
So there's a concept called localization in app development.
Yeah.
And I was wondering how does that tie into your system? Because you talk about personas and assign a human name to a case, but all the examples you gave were line operators, line managers, and like they were functional roles, and they were, those were not people. When you talk about people, then localization comes in because first it's just people, and second, in the scale that we're talking about, there might be this case where there's a line in Philippines, there's a line in Spain, and and the decision making is happening in say US or in like a different office. And do you think that localization has added another level of complexity, and are you addressing that at the moment, or is the next step localization?
Yes, yes, and yes. And yes. So localization is very important. All our applications go out, and I know this isn't localization, I'm just saying, we do translate all our software into 16 different languages upon release. So it has to be, and it's Cyrillic alphabet, so you have Greece, you have actually some of the Asian characters that go the other way. That's a little more rare because a lot of the companies that are paid from the various different companies, they negotiate to make sure the software stays in a similar fashion, even though it might be put in their local language, so there is some sacrifice back and forth in the manufacturing space. It is very important for color indicators not to be the only way to indicate something. From a cultural perspective, as well, meaning the meaning of colors, I mean, red in Japan means life, not death, like it would in North America or be associated with, so it's the exact opposite. So you have to make sure your iconography is up to snuff and your phrasing is correct. We try as much as possible not to render things with text in them, although sometimes that sacrifice has to be made based on size constraints and things like that. But we're constantly looking at that. I think the more and more the data gets integrated into the systems, like we get all this feedback, the ability to do more finite modelization will be much greater because people will be able to take the data and just say, in their local market, actually design their own app that makes sense to that area, just as long as it has the same outputs. Is that fair?
One last question.
Sure.
So when you're designing these plant and process models, do you have high-level tools that you use, or do you do raw coding for each implementation? Or,
Oh, no. We have model building software for the actual model of the plant based on different hierarchical plant hierarchy systems. We use S95, if you're familiar with that. Okay. So S95 model is pretty typical. It's a hierarchical model, enterprise, factories, all the lists, all that part, and then we hang everything off of that model. So it becomes a question of it goes all the way down to you get to the individual piece of equipment from that hierarchy, and then what sensors are tied to that, and what data do you expect to gather, and what data do you expect to report. So it's all built in that structure. We have tools we provide our integrators with to design that. And then we allow that, so that's an engineering design mapping function. And they get diagrams from the original people who designed the factory in the first place. And so they're translating that. So there is that initial paper process hasn't changed as of yet until those designers of factories actually start digital. And then at the tail end of that, we go from the piece of where it's an abstraction of that organization to going into simplicity or iFix, the tools I talked about, where we actually render the screens that represent the new environment. Did that answer your question?
Okay.
All righty, folks.
Well, thank you very much, Joe.
Thank you, folks.
Wonderful